Before any severe weather can occur, a thunderstorm must first develop. As surface heat, moisture, and instability grow, air parcels begin to rise and condense. Lifting mechanisms such as outflow boundaries and fronts can also help these parcels rise. As the updrafts rise and mature, they encounter wind shear in the atmosphere that allows them to rotate. These strongest thunderstorms can become supercells. Supercells are intense thunderstorms that contain rotating updrafts known as mesocyclones, and can contain high-level hazards including damaging straight-line winds, very large hail, frequent cloud-to-ground lightning, and tornadoes of all intensities. Classic supercells are structured like this. Inflow from the south and southeast feeds into the storm and up the rotating mesocyclone. The wind shear helps the mesocyclone to rotate, but also pushes the falling precipitation or downdraft away from the core of the storm, allowing it to maintain its strength. Below the mesocyclone, you can find what is known as a wall cloud. This is an area of lower pressure at the base of a supercell where tornadoes can form. So what actually is a tornado? A tornado is a violently rotating column of air in contact with the base of a thunderstorm and the ground. Tornado development truly begins even before a thunderstorm itself develops. Wind shear creates horizontal vorticity, and as heat and instability grow, updrafts rise, turning these horizontal tubes of air into the vertical mesocyclone. As a supercell matures, the rotating updraft begins to stretch and intensify. Lastly, the rear flank downdraft wraps around the backside of a mesocyclone and helps pull this rotation to the surface. Once all of these pieces come together in a correct balance, tornadogenesis can occur. Tornadoes are measured on the enhanced Fujita scale and are given a rating of 0 to 5 based on the damage they cause. Let's take a closer look at the scale and damage equivalents from past tornadoes. EF0 tornadoes have 65 to 85 mile per hour winds and cause minor damage such as breaking limbs off trees or ripping shingles off a roof. EF1 tornadoes, such as one that struck Dothan, Alabama in 2016, have 86 to 110 mile per hour winds. As winds reach 111 to 135 miles per hour, they are classified as EF2. Damage done to this mobile home in Damascus, Georgia clearly demonstrates an EF2's strength. At EF3 strength, 136 to 165 mile per hour winds cause even well-built structures to see considerable damage. Winds of 166 to 200 miles per hour are classified as EF4 tornadoes. EF4 tornadoes severely damage most structures, including schools, such as what occurred in Enterprise, Alabama in March 2008. EF5 tornadoes have winds in excess of 200 miles per hour and destroy everything in their path. This damage from Hackleburg, Alabama during the super outbreak of April 2011 clearly shows the devastating power of an EF5. A tornado watch is issued by the Storm Prediction Center when conditions are favorable for the development of tornadoes in a certain area at a given time. They are often issued before any severe weather is occurring. A tornado warning is issued by local National Weather Service offices when tornado development is imminent or occurring. A warning can be issued for one of three reasons. 1. A tornado is Doppler radar indicated. 2. Doppler radar confirms a tornado through correlation coefficient data. 3. A tornado has ground confirmation from the public or storm spotters. Strong tornadoes confirmed to be on the ground and causing considerable damage can be upgraded from tornado warnings to tornado emergencies. Doppler radar can determine the location and intensity of precipitation using its reflectivity product. Velocity products can be used to locate where mesocyclones and tornadoes may be forming based on the direction and speed of precipitation motion. During 2012, all WSR-88D Doppler radars were upgraded to dual polarization. This upgrade now allows radars to interpret data not only as reflectivity and velocity products, but also as correlation coefficient and differential reflectivity products. This graphic put together by the National Weather Service in Chicago, Illinois following an EF3 tornado shows how these products all work together to help confirm a tornado is on the ground. Reflectivity and velocity products can help determine where a tornado is located, but it cannot confirm that it is on the ground. Correlation coefficient and differential reflectivity can see tornadoes by using particle size correlation to determine what is precipitation and what is lofted debris. These two products complete the story and can bring confident confirmation to a tornado's likelihood of being on the ground. Before a tornado watch is issued, you should first develop an emergency plan in the case your area is threatened. Know where you need to shelter, so first ask yourself if your place of shelter is sufficient. Locations such as mobile homes, vehicles, and large open buildings such as a grocery store are poor options. An interior room of a well-constructed building away from windows, a basement, or a certified above or below ground storm shelter or safe room are good locations to shelter. If your only options are poor ones, consider going to a friend, family, or neighbor's home that is safer. If none are available, find a nearby storm shelter in your city or town. As COVID-19 is still a concern, continue to practice social distancing as necessary. If you do not have a storm shelter, when a tornado warning is issued, make your way to an interior room with no windows on the lowest level of your home, preferably a basement. In your safe place, put on a helmet to protect your head and wear hard-soled shoes, as well as cover yourself with a mattress and blankets. Let's watch as this family reacts to an approaching tornado. This family heard the alert, put down what they were doing, and made their way to their safe place, an interior bathroom. They put helmets on to protect their heads and put on their shoes. A mattress and blankets over the top of them would have given this family an extra level of protection from the threat. These steps will help keep you and your family the safest you can from an approaching tornado. We hope this brief dive into the basics of severe weather and tornadoes gives you some peace of mind as well as helps you plan how best to protect yourself and your loved ones when threatening severe weather approaches. During the summer and fall seasons, the Gulf Coast and eastern seaboard of the United States are on guard to the threat of tropical cyclones. The goal of meteorologists is to protect life and property, and one way this can be accomplished is by teaching and preparing citizens what they can expect and how to prepare if you are threatened by a tropical cyclone. A tropical cyclone is a rotating low-pressure weather system that has organized thunderstorm activity not associated with a front. NOAA's National Hurricane Center predicts and tracks these storm systems throughout the Atlantic Basin. Hurricane season begins on June 1st and ends on November 30th. The average peak of hurricane season takes place around September 10th, and a typical season averages around 12 storms. The main parts of a tropical cyclone, especially hurricanes, are the rain bands, the eye, and the eye wall. Air spirals in toward the center in a counterclockwise pattern in the northern hemisphere, clockwise in the southern hemisphere, and out the top in the opposite direction. The eye is a relatively calm and mostly cloud-free area of sinking air and light winds. The eye wall consists of a ring of tall thunderstorms that produce heavy rains and usually the strongest winds. Rain bands are curved bands of clouds and thunderstorms that trail away from the eye wall in a spiral fashion. These bands are capable of producing heavy bursts of rain and wind, as well as tornadoes. A tropical cyclone's greatest impacts often occur in the right front quadrant of the system relative to the storm's motion. Tropical cyclone strength is measured on the Saffir-Simpson scale based on a storm's maximum sustained surface wind speeds. Tropical cyclones with winds of less than 39 miles per hour are called tropical depressions. Those with maximum sustained winds between 39 and 73 miles per hour are considered tropical storms, and at 74 miles per hour, hurricane status is attained. Category 1 storms have winds from 74 to 95 miles per hour. Category 2 hurricanes have winds ranging from 96 to 110 miles per hour. Once a hurricane attains Category 3 status, it is considered a major hurricane, with winds from 111 to 129 miles per hour. Category 4 hurricanes have 130 to 156 mile per hour winds, and Category 5 storms exceed 157 miles per hour. While most people know that tropical cyclones contain damaging winds, many do not realize they also produce several other hazards. The first, storm surge. Storm surge is simply water that is pushed toward the shore by the force of the winds swirling around the storm. This advancing surge can combine with normal tides to create the hurricane storm tide and even higher water rise when wave action is considered. In low-lying areas near the coast, storm surge is often a significant threat. This animation shows the potential water rise heights from a landfalling hurricane in comparison to a 2-story home. At 3 feet, water can be in your home's yard. At 6 feet, water is into the first floor, and at greater than 12 feet, the water has likely inundated the first floor, forcing anyone inside to higher levels. Another hazard tropical cyclones have is torrential rains and inland flooding. Even after the winds have diminished, the flooding potential of these storms can remain for several days. 2017's Hurricane Harvey is a prime example, as it devastated the Houston, Texas metro with days of torrential rains. However, it doesn't take a powerful hurricane to create flooding disasters. Weaker tropical storms such as 2001's Tropical Storm Allison and 2019's Tropical Storm Imelda have caused issues for the Houston metro as well. Additionally, tropical cyclones can produce tornadoes that add to the storm's destructive power. Tornadoes are most likely to occur in the right front quadrant, often embedded in the rain bands well away from the center of these tropical cyclones. As part of the forecasting process ahead of a tropical system, meteorologists may share images like this. While it might look like a mess at first, this graphic can be quite beneficial in forecasting a storm's track, as well as who might receive the worst impacts. These are called spaghetti models, and each line belongs to an individual forecast model. While each model starts with the same or at least similar inputs, the outputs of a forecast end up different. In short, spaghetti models give you a way to see where a tropical storm or hurricane may head. It can also give insight into whether the models agree on the path of the storm or if there is a wide differing opinion on where the storm may go. From this set of models, they mostly agree the storm's track is for the Florida Panhandle. For those in the area, now is the time to prepare. So you and your home are about to be impacted by a hurricane. There are a few things to protect your home from the storm's impacts. First, clean your gutters. Second, trim all of your surrounding trees. And third, install plywood or window shutters to keep your windows safe. The storm is still a few days out, but you're looking to prepare an emergency kit just in the possibility that you're asked to evacuate. There are a few things to gather up to have as part of your emergency kit. Now for this, you need to have 10 days worth of supplies. So in this case, 10 days worth of non-perishable foods and water, a 10 days supply of medications for every member of your family, 10 days worth of clothing. Cash is a great option to always have, just for the potential that the location you're evacuating to is without power and has no way of accepting credit or debit cards. Important documents such as a COVID vaccination card, birth certificates, or even Social Security cards. A small first aid kit, a flashlight, a battery-powered radio, or even a crank radio would work as well. Now, if you go the battery route, make sure to have enough batteries to sustain that. Also, an external battery for any electronic devices, and your cell phone and all of its chargers that you might need for those 10 days. Stay safe.